Okay, before we go on with our program, here's a little diagram that explains the fields of a rectangle in XNA. We need four things to actually make up the rectangle. We need an x coordinate, we need a y coordinate, we need a width and a height. And the x coordinate in this case is the distance from here to the left edge, which is 200 pixels. And this is the distance from the top of the screen to the top edge of the rectangle, and that's 150 pixels. So x is 200, y is 150. The other two numbers you need the width, and this is coordinate number 600, but we're starting at x coordinate of 200, so the width is actually 400. And so we've got a width value right here, and there probably should be an arrow right here, but it's from here to here. And we also have a height, which is from here to here, and it is 200 pixels tall. Now, width, if I want to find out the coordinate of this line right here, I have to do a little bit of arithmetic. I have to add the x value and the width to get to 600. And if I want to find the actual coordinate of this line down here, I have to add the y value plus the height, which is 150 plus 200, and that gives me 350. Okay. Now, to make life a little bit easier for us, there are four other fields here. These are read-only. That means you can't assign a value to them. You can't put them on the left-hand side of an assignment statement. If you want to change anything about your rectangle, you have to change one of these four fields over here. But top is basically the same as y, except I can't use top on the left side of an assignment statement. And left is basically the same thing as x, but I can't use that on the left-hand side of an assignment statement either. But here's the neat part. I have a field called bottom, which is 350, which is the 150 plus the 200 is 350, and I don't have to add the y value plus the height. I can just refer to bottom, so that makes my life a little bit easier. And this value over here, the 600 on the x, can be obtained by adding the x value plus the width. But instead, there's a field called right that actually does the addition for you. So bottom and right especially come in handy to help you find the true coordinates of the bottom and the right edges of an XNA rectangle. Okay, now we're back in our program, and so you notice here I used screen.right instead of screen.width or screen.width plus screen.x, and here I use screen.bottom instead of screen.height or screen.y plus screen.height. So I'm already using those extra fields here of my rectangle. Now here's the neat thing about using variables from the screen rectangle in update here, like I'm using them. If I go change the values of my screen up on top, then this stuff all changes automatically down here. So let's go up here and let's have a rectangle that starts 100 pixels over. Actually, you know what? I'm going to leave it at 0 for right now. And let's make this 600, and let's make this 300. Okay. Now, I'm doing a random number location here to start it, and that could very well be outside of this rectangle. So what I'm going to do for just a minute here is I'm going to comment this out, and I'm going to comment this out. And then what I'm going to do is I'm going to just set them equal to 0 again. So it will always start in the upper left-hand corner of my rectangle. Actually, you know what? We can do better than that. Let's define our rectangle up here, okay? And then let's position our ball in the upper left-hand corner of our rectangle, regardless of what that is. So screen, whoops, dot, x, and this will be screen dot y, okay? And now I can pick anything I want to here. So let's do what I was going to do originally. Let's change this to 100, and let's change this to 100. So my screen rectangle is going to be 100 pixels over, 100 pixels down, and then 600 pixels go over to the 700 mark, and then down to the 400 mark. So it's almost a carved out rectangle in the center of the screen, but it's not quite the actual center of the screen. So let's run it. You should see the ball start 100 pixels in, 100 pixels down. somewhere up here in the upper left hand corner. Yeah, about right there. And now it is bouncing inside of that rectangle that goes down 100 pixels and goes over 100 pixels and stops 100 pixels from the right and stops I think 80 pixels from the bottom. But you can't see the edges here. It'd be kind of nice if you could actually see the edges. So we're going to make another little change here. And what we're going to do is we'll go back down here. We're going to draw the rectangle. And we'll just make it black for right now. So screen is, whoops, I need a texture to draw and I don't have one. However, I think I've got one. I don't have to go make one. I think I've got one. And if I go over here and let's just see if I have a blank rectangle or, okay, this says ball, but it's just a 30 by 30 white square. So I'm going to click on that. And I don't, actually it says ball. Let's see if we can find a rectangle here. That might actually be round, I'm not sure. So let's go down a little bit further and let's see. There's a white rectangle. It's 10 by 10. Doesn't matter that it's that small. We're going to stretch it to fill the background. Doesn't matter that it's white either because we're going to change color. So I'm going to add this. And so now I've got this white rectangle. Now I need a texture for my screen. So up here, after I declare the rectangle, let's declare a texture, 2D. Okay. And if we're going to have a texture, we have to read it in and load content. So screen texture equals content dot load. And it's rectangle, white 10 by 10. Okay. And then I want to draw it. And so I'm going to go down here. I'm going to draw the screen texture, comma, and screen. I didn't put rectangle on the end of it, so it's just plain old screen, but it is the right data type. And then color. If it's white, and you pick another color, we'll do blue. Make sure you do capital. Whatever color you pick is basically a color that you get. If you put any color on white, you get that color. Now, it's very important that down here you do these instructions in the right order. I have to draw the screen first and then the ball on top of it. If I turn these around, I'm going to draw the ball first, and then I'm going to draw a screen on top of it, and you'll never see the ball. So let's run the program now. We should have a blue background, which would be kind of a deep blue in front of that cornflower blue. And if we follow the bouncing ball here, because we use the screen coordinates, that screen rectangle variable, to determine where the edges of the screen were for the ball to bounce, it should be bouncing off the edges of the dark blue every time. And it is. So it is working. So the beauty of using this is that I can go in here and I can change these numbers to anything I want to. Okay, let's go in and make this 200 and 200, and let's just make it 200 wide and 200 tall. So it's going to be kind of a small area in the middle of our screen. But I didn't have to write a single line of code to make it work. And because it's a square 200 by 200, it's just going to be bouncing back and forth all the time. But I'm over about 200 pixels here, not about exactly 200 pixels, and I'm down 200 pixels here before it starts. And then I've got another square that's 200 by 200 with a bouncing ball in it. Okay. So let's make this 300 wide. And let's run it again so it just doesn't constantly bounce back and forth. Although I think we're going to see a repeating pattern here as well, but the repetition will take a little bit longer. and actually may take quite a bit longer. We'll know that we're repeating when it finally bounces back and actually hits the upper left hand corner, hits both edges of that upper left hand corner at the same time. And it looks like it's going to take a while to get there, but eventually I think it will get there. There we go, that's the halfway mark. Now it's going to go back and retrace all of its steps, and eventually it'll end up back in the upper left hand corner. But that's kind of cool. Now let's do a random position here inside of the rectangle. Okay, so if I want a random position inside the rectangle, okay, then I want to start at, there's another version of next here, and let me just back up over all this stuff so that we can actually see the version of next. Dot next, okay, and you see there's three versions. This will just give me a non-negative random integer. This will give me an integer from 0 up to, but not including that number. But this version will start at the minimum and go up to the maximum. Well, the minimum should be, for the x, should be screen.left. And the maximum should be screen.right. Okay. And down here for the y should be screen.top if I want it to be on the screen, and then screen.bottom. Okay, and now I should get a random position any place in there, and because I've got a smaller rectangle, I'm going to make a smaller ball as well. Let's make this 20, and actually let's make it go a little faster too. And now let's run it. Should start in a random position though. Okay. And a really neat thing that we did, I really want to emphasize this. A really neat thing that we did was we did not use any numbers down here. We didn't use 3s, so we don't have to go in here and change these to 3s. We just have to change things at the top, which is where you want it. Okay, change the value of an assignment statement, and then everything else looks at those values, those variables, rather than using constants. I could have built numbers like 800 in here for the width of the screen down in update, and I could have used 480. I could have used 0 for the left and 0 for the top. But if I did, and then I changed the size of my rectangle, I'd have to go down here and change all of this code. Now I don't have to. If I change the size of my rectangle up here, it's one change and everything. So I think I'll stop there, and we'll do one more video that demonstrates a few more things, and then we'll be done with this example.